Okay, ready? Some recapping here before we start multiplying and dividing. Monomial. What does that mean? One term. Add or subtract monomials. How can you add or subtract a monomial? What's the only way you can put them together?
If you have the same expression, you can only add or subtract them. Well, you need to
group together. You need to group together what?
Whoa. The like terms.
Like terms.
You're smart.
So adding and subtracting monomials. So there's an example. So it just means the only thing you can ever do to add or subtract them is to group together the like terms with each other. Okay, do you notice how 6y didn't have anything that looked like it? So I just have to leave it alone. I can't put it with anything. Right? Okay, an expression is a math statement using terms, and you need to have at least two terms. You can have what kinds of things involved? You can use coefficients, can be involved, right? You know what that is?
Yep.
A number in the front, like here, what's the coefficient?
5.
5.
Square.
You can use variables. So the variable is the x. You can use exponents. What doesn't an expression have in it?
An equal sign.
You don't have to write equals anything.
It also.
So for instance, I don't want something like at the very end, x equals 5. Like that's not what I'm trying to get. It's just an expression. Okay, and then let's recap the exponent laws. So what happens when you multiply? You add. What happens with division? Then we have to subtract. What happens when you have an exponent
Multiply
to another one? Then we multiply them. What can you do with something that looks like this?
Add the middles together and then multiply the total by the y. I don't know.
I can't do add down the middle. Why can't I do the add with the middle items? Yeah, so why wouldn't I be able to do...
Because the base is different.
The base is different. You can't do anything grouping if the base is different.
Or if you don't look at that.
So we're going to separate. And so we could do AMY, right? And then times a BNY.
Yep.
You can separate stuff. What's this rule? Anything to the 0 is 1. Okay. Here we go. Okay, so you can really think about doing this as, hey, what's going on with the coefficients? What's going on with the variables? So in this one, I'm going to do it the long way. I don't normally do it this way. I say, like, what's going on with the coefficients? Hey, there's a 5 coefficient, and then you're timesing by a 2 coefficient. And what's going on with the variables? There's an x, and there's an x. Another times. So then I've kind of separated my groups. So I'm going to say, well, what kind of coefficient would I end up with? 10. So that's the 5 times the 2. And then what kind of variable am I going to get out of this?
A W.
If you, what's the rule? What do you do when you multiply? What do you do? Add the exponents. So, what's on the top of this one? 1. What's on the top of this one? 1. So this is a 2. Do you guys know that when you tell me 2x, this is not 2x.
X to the power of 2.
These are different things. So telling me 2x is this, multiplying x by 2, I don't want that. X squared is timesing x by x. These are different things. Okay, so don't get that mixed up with your language. So don't call this 2x. It's x to the second degree.
And the power.
Or power of 2 or something like that, but not 2x because that's a coefficient. Okay, ready? So if I separate my ideas on what's happening coefficient, there's a 3 and there's a 2. And then what's the variable parts? So now my coefficient is 6. What happens with the variable part? What did you say? Copy it. Yeah, copy it. That's it. Why can I not go anywhere else with that besides just x, y?
Because, well,
You-
they're
you-
not really numbers because they're two different
No.
types of exponents.
No, you said it before. You had the same thing.
Different base.
Different base. If they have different bases, you can't do those rule things, right? You can't do those rules because they're not the same base. Okay, ready? Go, go. You got 2 here. You can do them quick.
I think I can do this pretty easy.
See what you get.
What do you need?
Okay. First answer. Did you get 8xy? Number 2, the second one, did you get -7?
X.
X squared.
Yes.
The number? Can you not do that, Easton? Or Coco, whoever is initiating it? Okay, here here we go. This says, write an expression for the area. How do you find the area of any general length times width? Okay, so in this case, the length, so the area, so we're going to go length times width. Doesn't matter which one is which, right? You could flip-flop that on your paper. Okay, do we all understand that brackets besides brackets means times? Brackets besides brackets, that's a times. Why did I do that? Because I didn't want to write the x symbol because the variable x, now we got a times x. That's all confusing. Okay, so take your coefficients. This coefficient times this coefficient. You could do this 8.6. And the variable part, if you have an x and times an x, x squared. Okay, same thing, area. So you set it up. What are you going to do to get area?
Oh, I'm on the wrong one.
Okay, so coefficient, oh, we got some big ones here. 28 times 16. Yee.
Will these be on the test? Is there a calculator on the test?
No calculator again.
Is that negative?
Will these big numbers be on the test?
28 times 16. So I get 48. 12 and 4 more. 16. Skip a place. 1 times 8. 1 times 2. Ooh, 448.
X 8. X to the power of 8. Or 6? Yeah. Or do we add them?
Oh, yeah.
What's the rule? If there's multiplying things together,
I'm sorry.
add.
I'm sorry, guys. I forget.
Okay. Quotient, so dividing. So same kind of idea, just backwards. So on your test, it talks about expansion. So this is what it looks like if I could break everything down, right? Okay. So here we go. I'm just going to chunk together stuff. So what do? I group coefficients with coefficients here. So what is negative 10 divided by 2? Negative 5. And what is our variable? What happens when we divide? We subtract. So this is a 2, subtract a secret 1.
1x, so like x. That's 1x, a single x.
Yeah.
X plus x minus x.
Okay, letter B here. So coefficient. So look at what you have for just your coefficients. 8 divided by 4. So I'm going to write a 2 there. Okay, let's talk about this part. Are we all seeing? I'm just going to separate this idea. X divided by x. Okay, so I could chunk those together because they were like each other. 8 divided by 4 was the 2. X divided by x, I can chunk that together because they're same base. So what is the exponent right on this thing? 1 and 1.
It equals 0.
So what does it make? X to the 0. And what is x to the 0? 1. Okay, do I have to write it when I times something by 1?
No.
No.
So it just end up being 2y.
2, and then y, because is there anything dividing it? No, or technically just like there's not a 1, it's not a 0, but it's a 1 on the bottom. So there's nothing you can do with the y, so it just is a copy. Okay? I kind of think about it like this as well. When something the same divides by something the same, it causes just a cancellation. It was the number 1. That's something that cancels. Okay? Anything divided by the same thing. Because think about numbers. What's 10 divided by 10? 1. 10 divided by 10 is 1. So what's x divided by x? 1. Okay, here we go. Give me your 2 answers here. Same questions that I just did. Go ahead. Okay, your first answer should be 7x. How did that go? Negative, negative divides to a positive, right? And question B should have 4x. Because I grouped those y's together and then causes them to disappear. Okay. So let's go to this.
We're doing 2 of them in the same day? Or you have time for the homework?
Yeah. This is all the same stuff. Just the same stuff. Okay, all this has done is added a binomial. Okay? So last time we did a monomial, monomial. Now this is a monomial, binomial. Okay?
Where is?
Is this not your next page?
Oh, yes.
Yep. Okay. Okay. So here's my question I always think about. Does this 3x multiplier apply to just something individually or the whole thing?
The whole thing.
The whole bracket has to get multiplied by 3x. Okay. So I'm going to have to multiply this together. I'm going to have to multiply those 2 items together.
6x2. 6x2.
And I'm also going to have to multiply those 2 items together. So this multiplier has to go to that and to that. So this is called distribution. Distribution. Okay, so now this would make 6x squared plus 12x. Okay. So on the next one, same idea. Can you write down the distribution property? So the distribution would be I have to do 2x by the x. That's the first item. And the 2x has to also go to the 3. Okay, so on your test, if I talk about distribution, that's what it is. You have to distribute it amongst everything. So the final would be 2x squared
Plus 12.
6x.
Please stop getting apples for them.
Oh,
That's what Carter said. Coco, that's what Carter, that's the way I go.
Okay, here we go. We got an area.
Coco. I was trying to give it to him. He gave me the notes, so I gave it back.
Coco is growing my
Okay, you know what? I would like to just finish this in 3 minutes, so can you actually just go sit into that open desk over there? And then so we can get through this. Okay, area of a rectangle. So give me an expression. What do you do for area, again, of a rectangle? Length times width, multiply. There we go. We got the multiplying of the sides. Okay? Now, step 2. Can you write me a distribution line? How do you distribute?
We distribute that into 4x equal groups.
So you have to do the 4x times the 5x first. You're also going to have to do a 4x times a negative. So there's going to be a negative in here, right? Because this is going to be a positive times positive, so this first term is positive, but this second term is going to end up negative. Do you see it? So I am not going to be too particular in how you write it because these are both fine. So here, did you see I added the negative 12x? And here I just went subtract 12x because those mean the same thing. Okay, do you want to try 2 on your own?
I don't feel like too about sure.
What do you do for like B if it's an X and a Y?
XY.
Okay.
Yeah.
5 times 11 equals 155. What? Yep, it's true. Absolutely.
Okay, so here's my answer. So here's the distribution of the negative 3x has to do that and that. How does yours look? Matched? Or did somebody write plus negative 15x? That's good too. Good. That's same. Fine. Brackets. Let's, how did you write brackets though? Did you write? If you wrote a bracket like that, it'd be wrong.
No, like in there.
Like this? Okay, that's fine. But if you put it in front of the negative, it would now look like you were just multiplying things. Yeah. Okay, so on this one, if I was to distribute, it would be 5y times the 11. Then it would be the 5y times a negative x. So distribute, so the 5y has to do both things. Okay, so this first should be 55y. And the next item should be subtract 5. You need to have or plus negative 5 xy. Okay, you can't combine. They're not the same letters. You can't put anything together. Did anybody write yx? Okay. If you did, it's all good. It's fine. Okay. If you ever see me writing things, I always write them alphabetical no matter what. So if I ever see a B times an A, I probably would never write BA, even though it's correct. I always write AB, just alphabetical.
I don't even know that,
Well, then you don't have to worry about it.
okay. B, E, C, D, W, Z, X, Y, W, Z, S,
Okay,
R.
okay, these ones are easy. Ready? This is back to the other lesson. Last page.
Then we have to finish our homework.
Okay, coefficient. What is the coefficient going to be here when I divide?
0. Oh, -3.
Just -3. There's no change.
Don't worry about it.
You're dividing it by 1.
What about the x? There's no change to x because there's nothing to put it with. And the y's,
It's canceled out.
they disappear, they cancel each other, yeah. Okay, and the next one, coefficient 4. What happens with a z squared divided by a z? 1.
Z1, so it's ZG.
2 subtract 1 is 1. Okay, so this is the last part. Determine the quotient. Okay, when you have a fraction that looks like this, it's implied like brackets. Okay? It's implied that that top is like a bracket group. So when you see something like that, it's an entire thing. Okay, so just like we did the multiply distribution, we are doing the same thing with the division distribution. So I have to do 6x squared divided by a 2x. I also am going to have to take the negative 8x and divide it by a 2x as well. So that's called a distribution of everything. So I get 3, and then the letter part, the variable part, x. This number is going to be a subtract 4 or plus negative 4. And the variable part,
Well, X cancels out X, so it's nothing.
so I don't write a variable.
Yep.
So that's a constant then. Okay, last 2 and I'm done. Can you write me a distribution of this?
Yes, you can.
So 3x squared divided by 3x. Yes. And 6x divided by 3x. They all have to do their turn. So there's my distribution. Okay, what happens to the coefficient here? What's 3 divided by 3? 1. Okay, I'm actually not going to write it because I don't really do 1 times something unless it's alone. What happens to x squared divided by x? Okay, if you write 1x, it's not wrong. It's not wrong. Okay? And here, 6 divided by 3, that's 2. X divided by x is something where it's same divided by same. So just 1. Okay, last one. All on your own. I'm writing, but I'm not helping you. So give me the distribution part.